Good day. What we have before us is a nucleosome model. This nucleosome was actually taken from the DNA protein database found on the internet. We downloaded a nucleosome, made a 3D model, sent it to be machined, and this is the actual physical representation of what a nucleosome really looks like. This nucleosome is highly flexible, bendable in virtually all directions, and extremely lightweight. Here we have our DNA coil. Now the purpose of this is to show you what this nucleosome is intended to do. A nucleosome assists in supercoiling. Basically what that means is that we take our strand of DNA, and we coil it roughly about 1.5 times around our nucleosome. Here you go. A nucleosome. Histone's DNA. Now we know that enzymes will sometimes approach nucleosomes and they'll find the tails, these outcroppings that are sticking out. When they do, one of two things happens. The tail will make physical contact with the DNA strand that's closest to it. And when it does that, it will produce either a tightening of the DNA strand, as you can see here, limited spaces, or when the histone tail makes physical contact, it'll produce a loosening of the DNA strand, as you can see here where my fingers are at. Now you might ask what importance this has. It has considerable importance because the histone tails actually decide what parts of the DNA strand can be used for DNA and protein synthesis. If an enzyme comes down, touches the tail, and tightens the DNA, then that means RNA, when it comes in to try to use this strand of DNA to create a template for protein synthesis, it can't get in. If an enzyme comes, makes contact with the histone tail, and the tail touches the DNA, and it loosens, then RNA polymerase can come in and it has enough room, as you can see, to work with this sequence of DNA and use it as a template for the creation of proteins. So that's basically the purpose of this model.